In this video, we're going to talk about working with the Linux command line. Specifically, we're going to talk about redirection and pipes. We'll also talk about a couple things related to wildcards and shell expansion. Now, there's a lot more in the notes, so make sure you read through the notes and understand what's going on there. What I'm touching on in this video are just the highlights, the most important things that you'll use a lot in the future. As a refresher, in Unix, there's three standard files: stdin, and that's your input stream; stdout, which is your output stream; and stderr, which is an error stream. And if you'll remember, we had this C file in the C examples where we wrote to stdout and stderr. So I compiled that already. If I run that, you can see that stdout and stderr both go to the terminal for output. Now I can do a command like this, ls-l, and there's some stuff that I have here. And I can redirect that to a file using the greater than symbol. And you can see now there's file listing.txt. There was no output from the ls to the terminal, but if I cat that file, you can see there's the output of ls. So if I try the same thing with my output, and this is going to overwrite that file. You'll notice we have 71 bytes and it was created at 1856. Now if we do ls-l, you can see that there's a new one that's 5 minutes newer and which is smaller. So I've overwritten that file completely. So if I cat the output, first off, notice that the stderr still went to the terminal and the stdout went to the file. So when I did that redirection, I'm redirecting standard output, but I'm not redirecting stderr. So if I want to redirect stderr, I can do that by indicating 2 before the greater than. And you'll notice I get stdout output at this time. And if I cat this error file, you can see that I have the error there. If I want to redirect both, if I use an ampersand, notice there's no output. And if I cat my output, that output file, notice both stderr and stdout are there. Now, why is this important? Imagine you're writing a C program and you want to keep logs, but if that's being used at the terminal, you may not necessarily want to have that stream visible. You might want to redirect the errors somewhere outside the console. So that would be an indicator where you might want to do just redirect stderr, or maybe everything you want to capture. So you could redirect stderr and stdout to that file, and then you can go back to that file later to review what the output is. So that's redirection. It allows us to write output of our program to a file. What if I don't care about the output? So let's do a.out, and let's say I don't really care about the output. So I can rewrite it to a special file called dev-null, and dev-null is a special place. If I write to this file, it just goes away. So there's no content there. If you redirect anything to that, then it just disappears off the system. You don't get terminal output, you don't get output to a file. So the next thing we want to talk about is piping. So piping lets us pass the output of a program as input to another program. So suppose I have ls-l again. So there's all the files that we've been working with. But suppose I want to only get files that I want to get a list of just the C files. So I could do ls-l star.c, and we'll talk about wildcards in a little bit. But you could also pass that output to grep. And so there you can see And the way that grep is aliased on my machine, I actually get a highlight of whatever it actually searched for. Or suppose I want everything but .text files. I could say ls-l, and then I can pipe that. That's a vertical bar. I could say grep-v .text. And notice now I didn't get any text files in my output. The -v says ignore. So I'm going to copy one of the C examples to this directory so that we can see how that works. Now, if I cat that file, I get a bunch of stuff. So I'm going to see where I use printfs in that. So I can grep for printf in that file. Okay, there we go. And related to this, it turns out that you can also do a redirection into a file. This takes the contents of this file and passes it as a input to this. And grep will read from standard input. So if you just type grep printf, it seems like nothing's happening, but it's waiting for me to type. So I'll say hello. But if I say printf, it's like, oh, hey, you typed printf. Don't worry too much about that. If you get stuck in that, a Control-C or a Control-D will get you out of that. And the redirection here is not super useful, but we have done some C programs where you'll pass the input this way. You could pass the file name as a command parameter, but for example, for the project, sometimes we write stuff that modifies files, and so we pass it in using indirection. So I forgot to mention that before, but that's something to keep in mind. Okay, so now let's talk about piping. Suppose we want to grep these printf files, and let's say I want to know how many there are. I can pipe that to wc, which is our word count function, and notice that tells me that there's 12 lines that include printf. Okay, or what if I want to see which lines have printf, but they also have an underscore? So there we see here's the 4 lines that have a printf and an underscore. So notice I'm getting some output, and then I'm passing it as input to this. Or I could even say add 10, let's say, and you can see that there's 2 printf statements that include add 10. And we'll actually use a lot of piping as we go through the semester, because one of the concepts in Unix is have a small utility that does something simple. Now, how well it holds to that, if you've looked at some of the man pages, they're pretty complicated. But you can do things like a find command that you pass to grep, or you can use some of the text manipulation features to do a lot of processing from a single command line. And we'll actually do that in the next video. So one of the questions that may come up is, okay, so what about standard in, standard out, standard error? How does that work? So if we go back and remember, if we run our standard out, standard error file, if I pipe that through, let's say, grep standard out, it does find that because it finds it here. And if I standard error, it doesn't find anything. That's just the standard error that we were already expecting. So this came from a.out because it was writing it to the error stream. Grep never actually saw it. So let's suppose that we want to pass standard error into the pipe as well. We do a.out, and then we say a pipe with an ampersand. And now notice both standard error and standard out both show up. If we just do without the ampersand, only standard out goes through there. So this came as output to standard error, so it's displayed on the terminal. This is the actual output from grep. And to demonstrate that, if we use the -n option, it'll give us a line number. So you can see this is the only output from grep. versus if we do the ampersand, both of those came from as output from grep. And we can chain as many commands as we want in a row. One other thing before we finish, now we have multiple C files. So I can do an ls-l *.c, and that gives me all the C files. I could also say, give me all the files that have a T in them, ls $T star. That's going to give me every file that has a T in the third position. So a question mark matches a single character, an asterisk matches one or more characters, or zero or more characters. So there's a lot of examples in the notes on how this shell expansion works. Make sure you understand there's a lot of tricks you can do to make your life easier. We're not going to go into them too much detail, but it's a good idea to read through those and decide which ones you find helpful and useful.